Today we'll be doing machine learning, as I stated. And so the example we use is called machine learning. You can find it on week 9 in the Moodle site, in the ARCL 01600 Moodle page. And there you can download the week 9 code. It's going to be using a Python library called SK or scikit-learn, which is a standard visualization and machine learning library used in Python, a fairly standard one. And it has a lot of different kind of tools which we can use for image analysis. The one that we'll be using, if you open the code, once you have it installed into your workspace, go ahead and open the SRC code. You will see the specific module that we'll be using today is called plot color quantization. You will see that a number of other ones, mostly sklearn or scikit-learn, as well as one in Keras. Another kind of image analysis as well as machine learning kind of library. We'll talk about that hopefully next week. But for this week, we want to use sklearn, a fairly standard one, library that is. And in terms of the specific analysis we'll be doing, it'll be looking at, as I mentioned, those two images and comparing them in terms of their colorization and how similar they are to each other. So if you go ahead and open plot color quantization.py in the SRC folder, you'll see in the code this week that we have something where we define a number of colors, so 64 colors, which is the number of colors we want in our output image. In one of our output images that compares to the base image. The base image is called china.jpg. It's a library that's in sklearn that we can use to test different machine learning algorithms. So it's the base image which has the full number of colors. I think it's over 9,000 some colors. It says it somewhere in the code, 96,000, excuse me, number of colors. So a huge number of colors that are in this base image. And then basically what we're going to do is represent that image in a kind of array, which we then represent the bytecode for that image. And then we're going to compare and then create the original image and then load it the example image, which effectively is like the base image. Except it has a fewer number of colors. It will have the 64 that we indicated from the top. And in this case, it'll use k-means clustering in line 59 to create the basic number of clusters, 64, or number of colors that are required in those 64 colors, or 64 clusters, excuse me, to create a comparable image. So basically what the k-means clustering does is take those 64 number of colors that we want and tries to find those 64 colors that best fit that number. So the best combination, effectively, of colors to recreate the image as similar as possible to the image that we have. And then what that then will do is then we'll create another image, a kind of image that is randomized, which will then be another number of 64 colors, but randomly selected instead of using k-means clustering. And that will then produce an image that we can compare to. So we'll have actually 3 images. One is the base image with 96,000 colors. The second is the k-means image, which has 64 colors, but is supposed to be as close as possible to the 96,000 color image. And the final image will just be a random selection of 64 colors just to compare to the k-means cluster. So basically it's a way for us to see how accurate our k-means clustering method is in finding an image or set of colors that most match or closest match to the base image. So we're trying to find a fairly effective way of showing the k-means clustering algorithm in terms of selecting 64 colors that are similar to the 96,000 number of colors that are used for the base image. So that's effectively the goal. I'm going to go ahead and also then explain to you what k-means clustering will actually do.